right here. If this is e to the x, then this function inverse is ln x. ln stands for the natural log. I don't know why the L comes first, probably because it's a foreign language that it, like French or something, I don't know. But the natural log is ln x, and that is the log function that pairs with e to the x. So section 2.3 covers that. So there's my natural log function, and the derivative of this is simply 1 over x. All right, so let's look at some examples. Let's suppose you have a constant multiple. And if we take the derivative, then we're just going to have the constant times the derivative, which is 1 over x. And that just simplifies as 10 over x. Now, what if your constant is inside the function? So let's suppose we have ln of 10x. Because it's inside the function, this no longer is just a plain old x, so it is a function composition with the natural log. So when we take the derivative, we're going to have to apply the chain rule. Now, just like we did with exponential functions, you just copy what you see. In this case, since we're dealing with the natural log, you just write the reciprocal of the input. So the input is 10x and the reciprocal is 1 over 10x. But then you have to apply the chain rule. You have to multiply by the derivative of what's inside here, and the derivative of 10x is 10. And interestingly, the 10s cancel. And so you simply have 1 over 10x, and that's your derivative. I'm sorry, 1 over x. Sorry, my brain froze there for a minute. 1 over x, that's what I meant, because the 10s cancel. All righty, so pretty simple. Basically, in general, if you have a positive constant multiplied by your x inside there, your derivative is always going to be 1 over x. All right, now we have the natural log of x squared. So the rule is you just take the reciprocal of your input. So the derivative is 1 over x squared. But because we have a function inside here, we have to take the derivative of that and multiply it. So that's the chain rule applied there. And we have 2 copies of x here. That's going to cancel with one of them. And so we're left with 2 over x. And just remember, this piece right here comes from the chain rule. Alrighty. Let's do an example with the product rule. We have y equals x squared times the natural log of x. Here we have a power function multiplied by a logarithmic function, so that's a product, and therefore we apply the product rule. And just to refresh your memory, y equals fg just means that the derivative is the first times the derivative of the second plus the second times the derivative of the first. Okay, applying that here, we have the first times the derivative of the second plus the second function times the derivative of the first. And simplifying, we have x squared divided by x, that's just x. And then we have 2x ln of x. Okay, whoops, sorry about that. I'll give you a moment to copy that since I was obstructing your view. And all right, so let's do an example using the quotient rule again. It's good to practice these rules. So this time we have y equals ln x over x. And applying the quotient rule, we have the bottom times the derivative of the top minus the top times the derivative of the bottom, which is 1. The derivative of x is 1. All divided by the bottom squared. And to simplify, x divided or times 1 over x or divided by x, however you want to say that, is simply 1. And here we have 1 times ln x, so it's 1 minus ln of x over x squared. And that is your derivative. All right. Now we're going to take the natural log of 9x squared minus 5x plus 6, and we want to find the derivative. So remember, the rule is for the natural log is you take the reciprocal of the inside. The inside piece is right here. We take the reciprocal, that's 1 over 9x squared minus 5x plus 6. But because this inside is not just plain old x, I have to multiply by the derivative of that polynomial inside there. So the derivative using the power rule is 2 times 9 is 18. Subtract 1 from the exponent leaves me with x. And then the derivative of negative 5x is negative 5. And the derivative of 6 is 0. So this just simplifies as 18x minus 5 divided by 9x squared minus 5x plus 6. Okay, and that is our derivative. So it's just, it's really not hard doing these problems. It's just knowing the rules. And you just have to practice. You'll get, the more you practice these, the more comfortable you will get with finding the derivative. Okay, so we're adding to our collection the derivative rule for e to the x for ln x. And I want to do, so we've got 10 rules now, but we're going to add yet a couple more today. So, but before I move on, I want to do an example from your homework where you have to find the equation of the tangent line to your function. Okay, so for example 7, find the equation of the tangent line to f of x equal ln x cubed. Now, the parentheses are very important because, let me just show you the difference here. A separate piece of paper. If you have ln x cubed, you might write that as ln x cubed like that, right? But that's very different. That's not the same as ln x cubed. So here you're taking the ln x function and cubing it, whereas here you're taking the natural log of the polynomial x cubed, or the power function x cubed. So they're very different things. So it's real important to use the parentheses in this problem, as I have done here. Now we are to find this tangent line at the point x. So I should put at x equal 10. All right. Now when you're looking for the tangent line, you first start with the slope. To find the slope, you need to know the derivative. The derivative of this, this is a little different than the problems we've been doing. Notice that the log function is inside the power function. And the other examples we did, it was the reverse. The power function was inside the log. So here we're going to just apply the power rule, and we have 3, and we take 1 from 3 to get 2. So this is the application of the power rule, but then we have to apply the chain rule by taking the derivative of this inside natural log. And the derivative of the natural log is 1 over x. Okay, so this is our derivative, and if I simplify that, I have 3/10 of the natural log of x, that quantity squared. Now in your homework, there's a problem very similar to this. And it tells you so be careful about those instructions. It says, do not use your calculator at this point. You want to hold on to this, because if you round your answer now from your calculator, and then you're going to, and I'm getting ahead of myself. I meant after you plug in the 10. So we're doing f prime of 10, 3/10 ln of 10 squared. If you calculate this on your calculator, you're going to have to round it. And then you're going to use that number to continue and finish the problem. Well, that's going to introduce error into your problem because you did that rounding. So hang on to this value, but this value here is your slope. Okay, that's your slope. Now we need to find b. B comes from the fact that y equals mx plus b. We know y, we know m, and we know x. How do we know y? Well, y is the function value when x equals 10. So if you calculate y, you just take this 10 and plug it into your function, and that is the natural log of 10, the whole thing cubed. Okay, this is your y value. So if I want to solve for b, I need to subtract the mx from both sides. And that means that b is equal to the y minus the mx. So to find b, I just need to plug in everything that I know. Y is this right here. I calculated that. Minus the m is this right here. And then your x is 10. So this 10 and this 10 will cancel, and I get that B equals ln 10 cubed minus 3 ln 10 squared. Okay, so I found m, and now you can use your calculator. M is 1.59 after you round it, and B is negative 3.69. All righty, and then so your equation of your line is approximately equal to 1.59. I'll just put a little approximate x minus 3.69. So what happened when a lot of students last semester were doing this problem? They would round it, and then they would carry this 1.59 in the calculation of B. So their answer was just a little bit off, and when they tried to enter it into MyLab Math, it counted it wrong, even though they were really close to the answer and they really did the work correctly. So just be mindful of that. They have those instructions in there for a reason, and if you don't follow those instructions, you're going to get frustrated. Anyway, so that finishes section 2.3. Now let me go ahead and continue with section 2.6.